Hello class, this is the next set of trigonometric identities, and in this video we'll be looking at double angles. By using the sum and difference identities, the double angle identities can be learned. In summary, we're actually going to be learning these three here. But I'll demonstrate to you that rather than trying to memorize these all the time, it's best if you can memorize definitely these sum and difference identities. You can always work from there. So let's demonstrate how you can easily memorize the rest from here. So if we let b is equal to a, we would get sine of a plus a. B is now a. In the exact same way now, this b will become a. So sine a cos a. Since it's plus, we also take plus for sine. Cos a and b will now become a. So that's sine a. Now since this is just multiplication, you can think of it like 3 times 2. We could easily write that out as 2 times 3. So I could switch this around, because it's just multiplication. The reason why I did that is because now these are like terms. Sine, 2 sine of a cos a, and that there is sine of 2a. That's how we get this expression here. The exact same thing can be done for cosine. So we let b equal a, so cos of a plus a. This will become cos a. B is now a. If it's plus, we must take minus. So minus sine a. Sine b is now also a. So this gives us cos of 2a equals cos a times cos a is cos squared a minus sine squared of a. And that's how we can easily find this if we can memorize the sum of 2 angles for cosine. The last thing can happen for tan as well. So tan of a plus a, this can be written as tan a plus tan, instead of b, it is now a, all over 1. Since it's plus, we must take the minus. Tan a times tan, and b becomes a once again, so tan a. So this will give us tan of 2a is equal to 2 tan a over 1 minus tan squared a. And that's how we find ourselves with these 3 identities. Now, as you can probably see, cos squared a minus sine squared a, that's the double angle identity for cosine. That looks very similar to the Pythagorean identities, which, if we actually combine it with them, we get the following. If we combine it with sine squared a plus cos squared a equals 1, rearranging this, we get sine squared a equals 1 minus cos squared a. So we just move this to the other side. Substituting this expression for sine, so instead of sine, we have this. That will give us cos squared a minus 1 minus cos squared a. Now really think about that. That's cos squared a minus 1. And that's going to be a minus minus cos squared a. That's plus cos squared a, which is this one here. Likewise, if we rearrange the Pythagorean identity and make cosine squared the subject, by moving sine to the other side, like so. We can substitute this here. So that will give us 1 minus sine squared a, which if we expand that, that's going to be 1. And now that's going to be negative sine squared a minus sine squared a. That's negative 2 sine squared a. So we can get even more identities from cos of 2a. One last thing that we can do is if we have this expression, remember this is cos 2a is equal to this. So here we have cos 2a is equal to 1 minus sine squared a. If we rearrange this, switch places, we get 2 sine squared a equals 1 minus cos 2a, dividing everything by 2 to cancel this. We get sine squared a equals half minus half cos 2a. This is how we will actually later on graph sine squared of a, because normally we can only graph things with sine, cos, and tan, but never with sine squared. The same logic can be applied for this. So we have the identity cos 2a. Remember, we can get it from here. Rearranging that, moving the plus 1. So 2 cos squared a is equal to 1 plus cos 2a. Halving everything, we get these two expressions. And this is how actually we'll be graphing y is equal to sine squared x and y equals cos squared x. Alright, so these are the identities we'll be using. The main thing I need for you to remember is are these three actually. I'll demonstrate to you in the next video how we might apply them to solve these equations here. Hope to see you then. Best of luck.